Good morning, my dear students. My name is Polaj Viswas, Department of Mechanical Engineering, JIS College of Engineering, Kolani. And the previous classes already discussed. This is the process controls. And the today discussion is the control charts. This is the lecture number 14. About to this is the subject quality and reliability engineering. And a few outlines will be concentrated according to this the control charts. And just like the outlines here, the control charts and the when second is the when to use control charts and the basic procedures. The quality control charts also will be here, and also the X bar charts will be given during to this presentations. And also the first is the control charts. The control chart is a graph used to study how a process changes over time, and this will be required the during to this the used to this the chart that like a graph, and also this will be study for this the how process change over time. And another thing is the data are plotted in the time orders. Data are plotted in time orders. A control chart always has a central line for the average, and the upper lines for this upper control limits also will be concentrated according to this. Like the control chart always has a some central lines for this the average, and the upper lines for this the upper control limits, and the lower lines for this the lower control limits. And these lines are determined from historical data also will be found. And another thing, the by comparing the current data to these lines also here, and you can draw conclusions about whether the process variable variations is consistent in a control, or the unpredictables out of this controls affected by special causes of variations also here. And these versatile data collections and the analysis tools can be used by a variety of industries, and is considered on of the 7 basics quality tools also will be concentrated according to this the control charts. That like the this will be required for this the unpredictables out of the control affected by the special causes of variations here. And these versatile data collections and the analysis tools can be used by a variety of industries, and is considered on the 7 basics quality tools also will be mentioned. And another things you can find, the control charts for variable data are used in pairs, and this also will be used for this the pairs. The top chart monitors the average for the centerings of the distribution data from this the process will be here. That's like the this is the top charts monitors the average. The top chart monitors the average or the centerings of the distributions of the distribution of data from the process will be here. The bottom chart monitors the range. The bottom top chart and the bottom chart, those will be monitors. The top chart monitors or the centerings of the distributions of data from the process, and the bottom chart monitors the range or the width of the distributions will be here. If your data were short in the target practice also here. That's like your data were the short in the target practice, the average is where the shorts are clusterings, and the shorts are the clusterings here, and the range is how tightly they are clustered. That's like few will be required for this the clustering, and how this will be the range of this the tightly they are the clusters. And the control charts for attributes data are used slightly, and this will be here the width of the distributions. If your data where the shorts in targets practice, the average in is where the shorts are clusterings, and the range is how target tightly they are clustered. And another things, the control charts for the attributes data are used for this the signly, and when to use a control charts. This will be very essential. The where is used to this the control chart, and another thing is the when to use the control charts. And this is the basic procedure or the create a control charts, and this will be essential. And another thing is the controls are resources, and where you have to given some resource during to this the period of this the control charts. And basically this will be considered according to this the chart will be prepared, and just like the some variables will be here, and some data will be monitoring, and also given some data, and also you have to prepare the charts, and these charts will be required to this the plan also, and also this will be required for this the creating a control charts. And sometimes you have to required for this the control chart resources, and when to use a control chart. And this is the first things will be here, when to use a control chart. The control chart is used when this use required for a use to use a control chart when controlling outgoing process by finding the correcting problems as they occurs, when predicting the expected range of outcomes from a process, when the determining whether a process is stable in statistical controls also here. The basically the controlling outgoing process will be required, and but you have to found to this the correcting problems as they occur. And another things when the predicting the expected range of outcomes from a process, by determining the whether a process is stable. The process is stable, that like you have to control to this the statistical controls here. And the when analyzing patterns, the analyzing patterns of process variations, and this will be required for this the process variations from the special causes, and that like the special causes also will be here. The non-routine events will be found, and or the common causes but into the process. The few cases we can see to this the common causes but built in this, into the process here. The when the determining whether the your quality improvement project should aim to prevent the specified problems or to make the fundamental change to the process, and then you have to use when the determine the whether your quality improvements projects, the quality improvement projects should aim to prevent the specific problems or to make the fundamental change to the process also will be concentrated. And another things will be there, the basic procedures will be considered according to this the control charts. And that's like the you can see here the chose the appropriate control chart for your data, and you have to always the given some data, this is like the inputs, and also you have to appropriate control charts for your data you have to choosing. And another things that determine the appropriate time periods, and determine the appropriate time periods for collecting and plotting data, and these things that you have to given the basic procedure the chose the appropriate control charts for your data. And another things you have to determine the appropriate time period, that like for collecting and plotting data, that like you have to collect and the plotting data. And another things the collect data constructs your chart, analyze the data, and because you have to collect some data, and you have to given to this data to this the constructs your chart, and during applying to this the data, like or the Excel sheets also will be available during to this the basic procedure you have to maintain, that then determine the appropriate time periods for this the collecting and the plotting data. And another things the collecting data constructs your chart and analyze the data, and this collecting data always the construct your chart and also analyze the data will be here. And another things will concentrate for this the look for out of control signals, and this will be the looks for this the out of control signals also here on the control charts. When one is identified, and when one is identified, and the mark it on the charts and investigate the causes, and this will be investigate the causes, that like the look for out of control signals on the control charts. When one is identified, and the one is required to this the identified, that like the mark it on the chart and investigated the causes, that like the required for this the investigated of the causes, how this will be not some obstruction also will be there, some defects will become, that this will be concentrated according to this the that like the first investigated the causes. Either you cannot be solve your problems, you have to recording for this the solving problem, that's first will be investigated the what will be cause and the where is the comes from this the cause. And the another things documents how you investigate the document also will be recorded how you investigate what you learned, that is like the documents how you investigate what you learned, the causes and how it was corrected. And that's like the documentation will be recorded, this like the how you investigated. The first will be investigated is the how it will be investigated. Another thing what you learn, that like the always you have to learn something, that like the what you learn, the cause and how it was corrected, and that like the cause also will be here and also how it was corrected will be here. And the another things the during to this the basic procedures also will be here. The out of control signals also is the concentrate. According to this, the out of control signals, and these out of control signals you have to here the a signal point outside a signal this single point outside the control limits is the here, and this like the in figure on the point 16 is above upper control limits will be given. Just like that, this is the figure on the control charts out of this the single line, and you have to concentrate according to this the point 16 above to this the upper limit. Just like you have to see that this is the given here the x, and just like the figure point on is the 16 is the above to this the upper limit control upper control limits. And another thing, the 2 out of 3 successive points, the 2 out of the 3 successive points are on the same side of the center lines, and the further than the 2 sigma from it also will be here. Just like that, you can see that during to this the figure, and or the control charts out of this the control signals, you can see during to the 1 sigma 2 sigma will be given. That just like the this one is the 2 sigma, and this is control to this the upper control line. Similarly, the 2 out of the 3 successive points are on the same sides of the center line, and further than 2 sigma from it, and in figure on point 4 sends that signal. That's like the 1 to point 4 will be sent to this the signal. That like the this is the 1 and this is the 4. You have to given to this the signals. Send that signals, and another for out of 5 successive points are on the same side of the center line, and further than 1 sigma from it, and this basically this will be 1 sigma. That's like the out of 4 successive points are on the same side of the center line, and further than 1 sigma from it. In figure on, the point 11 sends that signal. The point on this will be considered 11 sends that signal. A run of 8 in a row are on the same side of the center line, or the 10 out of 11, 12 out of 14 out of or 16 out of 20, and you can here the a run of 8 in row are on the same sides of the center lines. That like the or 10 out of 11, 12 or out of 40s or 16s out of 20. In figure on points 21 is 8 in the row above the center lines, and the obvious consistence or the persistent patterns that suggest something unusual about your the data and your process. You can see the according to this the one is considered according the obviously consists of the persistent pattern that suggests something unusual about your data and your process. You have to see that this will be the on a figure will be the control charts out of the control signal figures. We have to concentrate according to the continue to the plot data as they are generated. The continue to plot data as they are generated as each new data point is plotted. The check for new out of this the control signals also will be here during to this the point 5. That's like the you have to continue to plot the data as they are generated, and as each new data point is plotted, check for new out of the control signals. You have to concentrate according to this the point 6. When you start a new control chart, start a new control charts, the process may be out of control. This process may be out of control. If so, the control limits calculated from the first 20 points are conditions limits. Also, this will be the first 20 points. Just like the you can see this is the out of 25 points is the first 20 points will be considered are conditional limits, and when you have at least 20 sequential points from the period when the process is operating in control, calculates from this the control limits. That like the out of 25, this will be concentrated according to this the first 20 points are the conditional limits. When we have at least 20 sequential points from the period when the process is operating in a controls, and also the recalculated the control limits also will be required for the according to this the out of the control signals. That like the basic procedures also will be the discussed. And another things, the create a control charts, and how we can be create a control charts. This template stated a statistical process control. The SPC charts also will be given during to this a details discussion of the specific statistic process control charts in the can be found to this on. And the individual data you have to first apply to this the individual data to this, and also you have to found this will be the control charts. And the another things, this will be the moving range charts also will be there, and the sigma limits also will be concentrated according to this a single point outside the control limits, and the 2 sigma limits also will be here. The 2 of the 3 points outside the 2 sigma limits also will be here. The 1 sigma limits, the 4 or 5 points outside the 1 sigma limits, and the average the 8 is 8 in a row of the same sides of the central lines also will be here. And the basically the you have to concentrate according to this the create a control charts. You have to first given the few data, and also this will be concentrate according to this the Excel sheets, and you have to putting this value the just like the individual data, and just like the moving range chart also will be concentrate according to this. And also you have to given the different data, and also you have to prepare for this the specific quality control process control charts, and this will be details given during to this charts. And also the moving charts also will be here. The what is the 3 sigma limits, and the 2 sigma limits, the 1 sigma limits, and also the average points will be concentrated according to the single point outstanding the control limits, the 2 of the 3 points outside the 2 sigma limits, and also the 4 or 5 points outside the 1 sigma limits also will be concentrated according to the 8 in a row, and the same sides of this the center line you can be concentrated according to this the quality control charts. That like the you have to find to this one the according to this the out of port the out of ports you have to use to this the control chart resources also. The control chart resources also will be considered according to this the create a control charts, and the monitoring system the quality control charts also will be concentrated. The basically the quality control charts quality control charts represent a great tool for engineering to monitors if a process is under statistical control. Now that's like the quality control charts represent a great tool for engineering to monitor if a process is under statistical control. They help visualize variations. They help the visualize variations and the find and correct problems. That's like the find and correct problems when they occurs. And that's like the they occurs. The predict expected range of outcomes and analyze patterns of process variations from the special or common causes you can find. That's like the quality control charts represent a great tools for the engineering to monitor if a process is under statistical control. They help the visualize variations, find and correct problems when they occur, predict expected range for outcomes, and analyze patterns of process variations from special or common causes. And the another thing, the quality control charts are often used in the Lean Six Sigma projects and the DMAIC projects under the control phase, and are the considered as one of 7 basic quality tool for the process improvements also will be found. That like the quality control charts are often used for the Lean Six Sigma projects and DMAIC projects under the control phase, and are considered as one of the 7 basic quality tool for the process improvements you have to consider. However, how can we determine the right quality control charts? We can determine the right quality control chart to use for monitoring a process. That's like the right for this the quality control charts to use for monitoring a process. The following decisions, the decisions tree can be used to identify which is the correct quality control charts. That's like the following decisions tree can be used to identify which is the correct quality control chart to use the based on the given data. That like the quality control charts for this the AX bar charts, AS charts, and the process capability analysis also will be concentrated according to this the quality control charts for the AX charts. And AX bar charts, the quality control charts represent a great tool for engineering to monitor if a process is under that like the AS chart. In order to use the AS chart along with the AX bar charts also will be here. That like the AS chart, this will be considered according to this the use the AS charts along with the AX bar chart. The sample size n must be greater than 10. That like the sample size n must be greater than 10. And another process capability analysis. The process capability is a statistical measure. That like the process capability is a statistical measure of the inherent process variability. That like the process capability analysis to this the process capability is a statistical measure of the inherent process variability. And concluding throughout also here the you have to concentrate according to this figure that like the which control charts should you use. That like the one is the you can think the continuous or discrete data also will be found. Just like the first will be given to this the continuous and the discrete data, and another things will be given the this will be the continuous data will be here. That like the what is the sample size. That like the n will be calculated. What will be the sample size? That means you have to flow to this the continuous data, and another thing will be here. The discrete data also will be found. That like the on defects will be comes. The first things we have to concentrate according to this the which control charts should use you used. That like the first will be required to this the continuous data, and the discrete data will be required. That like the continuous data, what is the sample size in? The first is the what is the sample size, and the second is the discrete data will be that like the defects. The what is the sample size, and the n will be n equals to 1 when the value the sample size n size equals to 1. That like n equals to 1, the x m r by I mr charts will be here. That like the first is the n value is the 1. That like the x mr plus I mr charts also will be concentrated according to this that like the values or the slot size is the 1. Another thing, the slot size, the value is the 1 less than n less than 11. That like the x bar r charts also will be here during to this the sample size is the n value is the 1 less than n less than 11, and then like the x bar r charts also will be concentrated. Another thing, the n value is depends is the greater than 10. That like the greater than 10. That like the x bar s charts also will be calculated during found. That like your the continuous data will be comes, and another the discrete data, this will be calculated to this the defects of this data. That like the discrete data you have to calculate to this the defects, and the defects will be coming to this the multiple defects per units or the one defects per unit. This will be much more essential. That like the always you have to concentrate according to this the zero defects, but you have to find to this the defects. That is the which type of defects will become. This will be the one defects per unit or the multiple defects per unit. That like you concentrate according to this the one defects per unit. That like the constant sample size, you have to always consider according to this the constant sample size. The constant sample size, your sample size is not the larger or higher. This will be always maintained according to this the constant sample size. But this the constant sample size will be here. This is the yes or no. Then you have to concentrate according to your the constant sample size is yes. Then NP chart also will be concentrate according to this the constant sample size will be the same size of sample will be come out. That like that this will be the yes, and the NP charts will be there. Another things, the constant sample size is the no, but the different size of sample will be found. That like this will be constant sample size is no, and you have to find to this the P chart. That like the NP chart, then another is the P charts will be calculated during to this the one defect per units. That like the you have to consider according to this the not constant sample will be produced during to this. That like you have to concentrate according to the P charts. another things you have to calculate it during to this the multiple defect per units, that like the constant sample size or the this will be always concentrated according to this the constant sample size, or the there is the different type of control size will be found, that like the multiple defects per units you have to constant sample size, yes, then you have to concentrate according to this the C chart, that like the your sample size is the constant, but you have to come to this the multiple defects per units, that like that you have to concentrate according to the C chart. And the another things will be there, but the multiple defects will become, but your the sample size is the not constant, that like the different size of sample you have to concentrate during to the defects per units, multiple defects per unit, then you have to concentrate your the U charts, and like the no constant sample will be found, that like you will be concentrate according to the U charts, and this will be analysis the which control chart should be used, that like the which type of control charts you have to use according to your the requirements, you have to concentrate according to this the figure. And the another things we have to hear the X bar chart. The X bar and S charts are quality control chart used to monitor the mean and variations. That is like the X bar and S bar S charts are quality control charts used to monitor the mean and variations of a process based on samples taken in a given time. This is like the given time. The control limits in on both charts are used to monitor. The control limits on both charts are used to monitor the mean and variations of the process going forward, and this will be the process going to this the forward. If a point is out of the control limits, the point is out of the control limits in indicates that the mean or variations of the process is out of control, and that like the your process is out of controls. And for this the if a point is out of the control limits, it indicates that the mean or variations of the process is out of controls, that like the as a single signal level, the signal level causes may be suspected at this points on the X bar charts. That's like the your X bar charts you have to as signal levels also will be causes, that the signal cause will be may be suspected on this the points on the X bar charts. The Y axis shows the grand mean, and the control limits with the X axis shows the sample group. That like the X bar charts and the Y axis shows the grand mean, and the control limits with the X axis shows the sample groups. And the take a look at the R code using the QCC package to the generate of the X bar charts also will be here. Okay, and you have to showing to this one to this that like the X bar and the S charts also will be the concentrate according to the generate of the X bar charts. And the next class discussion the statistical quality control tools. Okay, thank you my dear students.